So, applications day today of the law of sines and the law of cosines. Definitely need a calculator today. And then we'll be in your green packet after the first one. And then I got a bunch. I just went through the grades this morning. I got a bunch of people that haven't done the formative and or the worksheet from last week, and it's progress time. Today technically is the end of progress, okay? But so we have to have we have to submit our progress grades, I think, by Monday. So if you want it to show up on progress, or you're missing a test or a quiz, or you got some stuff to fix, okay? Now's the time. Now's the time to get that stuff done. Okay? So let's start out with a warm-up here. Excuse me. Please solve this triangle. This is, again, not in your green packet. This is going to be, you can do this on the back of a sheet of paper, or you can do this on, a scrap or something like that. So I like to start drawing myself a little triangle, labeling that triangle. Figuring out what we need in that triangle. Okay? So this is an angle side-side case. So we need to check what we got. Well, we've got an acute angle. So then we should check our relationship between the opposite and the adjacent side. And I see that the adjacent side is longer than the opposite side. Correct? That means we have to check the height. So let's check the height. So dot, 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 dot. The sine of 35 degrees is equal to h over 17.5. So that means that h then is 17.5 times the sine of 35 degrees, which I get is 10.0376. Concur? Should. So that means what? 0 triangles, 1 triangle, 2 triangles. It means 2 triangles. Yep. So, first triangle, we find normally using law of the sines. So, sine of 35 degrees all over 15 is equal to the sine of angle B sub 1 all over 17.5. 15 sines of angle B sub 1 is 17.5 sines of 35 degrees. This is what you were talking about, right, Jade?
Yeah.
Yep. Yep. So I get angle B sub 1 is the inverse sine of that, which I get is 42.003 or something like that, right? So let's call it 42. Agree? Love it. Angle C sub 1 is, depending on what you rounded it to, 103.0 degrees or 102.997 degrees or whatever, you somewhere in there. Yeah. Then I get side C sub 1 here is, I got 25.48. Depending upon your rounding, you might be a little off on that. Okay, I left mine as exact all the way through. Good so far? So that's triangle numero uno. Then we have to go back now and we have to do triangle number 2. So blue. So angle B sub 2 is going to equal 180 degrees minus angle B sub 1. So I get angle B sub 2 is approximately 138.0 degrees. Or if you didn't round or you rounded to 3, 137.997. Angle C sub 2 is going to be 180 degrees minus 35 degrees minus 138.0 degrees. I get angle C sub 2 is 7 degrees. Oh, my Atlanta. All right, so then we're there, we're good to go. Yes. So now we just have to run a little sine of 35 degrees divided by 15 is going to equal the sine of 7.0 degrees divided by side C point or C sub 2. Have a good day, buddy. Thank you. Yep. C sub 2 sines of 35 degrees. Across from the main office.
All right,
Yeah.
thank you.
Yep, no problem. Sine C sub 2 is 15 sines of 7.0 divided by the sine of 35 degrees. Lower. So side C sub 2 I get is 3.1 units. Yes? No? Questions? Again, might be a little off on those last two, depending upon your rounding. And I'm okay with that, as long as you're close. If you got like 92 instead of 25, then we've got issues. Okay? But if you got like 26 or 25, somewhere in that 26 to 25 range, you should be okay. Okay? At homers, any questions? No? Fantastic, love it. All right, now we're in the green packet. Okay, so we're going to be on those two word problems ones. So this is number 1 on the 5.5 class examples. One. So there's one side is 5.5, the other side is 5.6. So this is number 1 on 5.6. Okay. Word problem, application type thing. Okay. A plane flies 500 kilometers, and I would definitely read these problems first so that we can figure out the picture from there. A plane flies 500 kilometers with a bearing of north 44 degrees west. Whoa, tap the brakes. Bearings. Okay? It's just what it says. Okay? You gotta just remember that in life, north is up, south is down. Okay? West is left, east is to the right. I won't say east is right because east is wrong. Okay? So remember, it spells out we across the middle. Okay? So north 44 degrees west means you're going in a northerly direction, and then you're going 44 degrees to the west. Okay? So north 44 degrees would be kind of up and to the left. With me? Okay. From B to C. The plane then flies 720 kilometers from point C to point A. Point A is due west of point B. Find the bearing of the flight from C to A. All right, that's not bad. So let's start with a picture. So we've got point B right there. We know that the bearing of north 44 degrees west, north is up, west is left. So this angle in here is my 44-degree angle. That gets me to point C. Then it says the plane flies to point A, which is due west of point B. So that's a horizontal line then. And there's my triangle. It also says that this is 500 kilometers and this is 720 kilometers. Would you agree with my triangle as drawn? Okay? Do we know any angles inside our triangle? Because so angle B, the angle B inside of our triangle, this angle right here would be 46 degrees because north and west are perpendicular. Love it. Okay? So, what do you think we need to find? Angle A. Let's go back to our problem. It says find the bearing of the flight from C to A. So that's this flight going that direction, correct? So we need to find angle C. Yep. We need to find angle C. Okay? So let's look at our particular triangle. It's an angle side-side case, isn't it? Yeah? Okay. So let's go through our steps just to make sure that we aren't looking for two angles. Our given angle is acute. So that's good. We need to check then the relationship between the opposite side and the adjacent side. Which one's bigger? To the red angle. The opposite side or the adjacent side? Opposite. So opposite is bigger. That's good because that means we only get one triangle. Anytime the opposite side is bigger, we only get one triangle. Okay? So we can just go law of sines now. So the law of sines says the sine of 46 degrees divided by 720 is going to equal the sine of angle A divided by 500. So we actually do have to find angle A in order to find angle C, which is fine. So 720 sines of angle A is 500 sines of 46 degrees. Sine of angle A is that divided by 720. Did you get one? Oh, okay. What do you got? Yep. Love it. Okay. So then angle C is going to be 180 minus 46 minus that. And I get angle C is 104.03 degrees. Correct? Okay. So now let's look here at angle C. All of angle C is 104.03 degrees, correct? But bearing, way up here, bearing is always going to be of the form north or south, an acute angle, east or west. Okay, that's the form of bearing. So we have to take this and we've got to adjust it. Because I really just want this angle right there, that purple angle. If I know that this angle down here is 46 degrees. And that's going to make a right triangle. What's this angle up in here? What's this orange angle? If I've got a right triangle and my base angle is 46. 44. Yep, this one's going to be 44. So then what's the purple angle going to be? $60.03, right? So the final bearing then is going to be, let's go back here now. We'll go back up here. So the final bearing, you're back. So the final bearing, are we headed in a north, up or down on the direction? Down. So that's going to be south, right? Okay. So down is south. Then the angle that we're heading off of the vertical is 60.03 degrees. And is that on the west side or on the east side? It's on the west side. So there is our bearing from point C to point A. Phew! Got to use some logic. Huh? If I was to just watch the video on that one, because that one's woo doggy. All right. Okay? Good? All right. I would like you, this is now number 2 on the next sheet, on the 5.6 sheet, number 2. I'd like you to try this one. So a 100-foot tower is to be built on the side of a hill that has a 6-degree slope with the horizontal. Find the length of each of the 2 guide wires. Those are the wires that keep it from tipping over in the wind. Okay? Find the length of the guide wires that will be anchored 75 feet up and 75 feet down from the base of the tower. All right, sounds good. So we've got a hill, and that hill is at a 6-degree slope. I don't want anything from you. Okay? Then we're going to put a tower on that hill, and that tower is going to be vertical. Because why would you build a tower at an angle? It doesn't make any sense. Okay? Then we're going to place 75 feet up the hill and 75 feet down the hill. We're going to place these guide wires. We need to know how much wire to spool out of our spool to figure that out. All right. We know that the tower is 100 degrees or 100 feet too. Okay. So if this is 6 degrees in there too, right? That helps. Wink, wink, nudge, nudge. Yeah, that's going to help us a little bit right there. So there's our picture. You try it. Find out the rest of the answers. So that angle, going green, that angle right there, that angle is going to be 84 degrees. Agree? So is this a law of sines or a law of cosines case? Law of cosines case. Yep. So up squared is going to be 100 squared plus 75 squared minus 2 times 100 times 75 times the cosine of 84 degrees. Type all that into the calculator, and I get up squared is 14057.1. So I get the uphill guide wire has to be 118.563 feet long. On the downside, if this angle, the green angle, was 84 degrees, then the downside angle would be 96 degrees. And again, we are in a law of cosine case. So the down wire quantity squared is going to equal 100 squared plus 75 squared minus 2 times 100 times 75 times the cosine, but now of 96 degrees. And that gives me, when I type that in, 17192.9. So the down wire, or the downhill side guide wire, needs to be 131.122 feet. And again, I rounded to 3. You can round to whatever. Yeah? Great, grand, and wonderful? Great, grand, and wonderful. We'll go through this next one with the picture, but then I want you to actually do all of the maths around it. Okay? So, a boat is sailing due east, parallel to the shoreline, at a speed of 10 miles per hour. At a given time, the bearing to the lighthouse is south 70 degrees east, and 15 minutes later, the bearing is south 63 degrees east. Okay, love it. Find the distance the boat is from the shoreline if the lighthouse is at the shore. Okay. Okay. So we've got a boat, and it's sailing along a path. That path is parallel to the shoreline. Somewhere on the shoreline, that's my lighthouse. You got a lighthouse. At the moment, at the first one, we are south 70 degrees and east, which means then that this angle inside this potential triangle would be 20 degrees. 15 minutes later, now the boat is here. now the angle is 63 degrees, which means this whole angle, how big is this whole angle here? How big is the blue angle? What you got? 153?
Yeah.
Yep, 153. Okay. Which means, how big is this shoreline angle? Seven. Yep. Okay. So we got the three angles of our triangle, right? We just need a side now, right? Well, if the boat is traveling at 10 miles an hour for 15 minutes, how far did it go? What do you got? Went 2.5 miles. Exactly. It went 2.5 miles. Okay. We want to find, if this boat is traveling parallel, we want to find this distance right there. We want to find that distance to the shore, which could easily slide anywhere along here, because that distance is always going to be the same. So if you want to slide it anywhere along there, you can. Okay? Find me the distance to the shoreline. When I was doing this last hour, I found the big long side X. Okay? We could have also found the other side Y. You got to find one of the two sides. Doesn't matter which one you find. Okay? So I said that the sine of 7 degrees over 2.5 is equal to the sine of 153 degrees divided by x. But you could have also gone the sine of 20 degrees and done y. Either one, doesn't matter. Okay? Two paths are going to diverge in the woods. We're going to go around the lake and we're going to meet up on the other side. Okay? So I got x sine of 7 degrees is 2.5 times the sine of 153 degrees. So I got x here as 9.31306. With me? Okay. Then I said to myself, if we break out that triangle from the boat's first position, this is what we just found. We know that this is 70 degrees. We know that this is a right triangle, and we want to find D. So I would just say then that the cosine of 70 degrees is equal to D divided by the one that I chose. If you solve for the other side, it would be the same, except your angle would be 63 degrees. Okay? So you'd have the cosine of 63 degrees equals D divided by some different number, whatever you got for Y. Okay? And so I got the distance from shore was 3.18525. So the boat is about 3.19 miles off. Okay? Love it. So the remaining time, you got 3 more problems in there to do. All of the answers will be, I believe, posted on the interwebs. Actually, I think on the law of cosine ones, you have the answers right in the end of the problems. Yep, right at the end of the problems, you have the answers to the cosine ones. And the sine ones, I'll tell you what the other one is. But again, don't forget to make this one change on the one example that we didn't do yet. You want to change this 2 to an and right there. Okay? This makes a huge difference. Okay? So make that one change, please, on number, I believe it's number 3. Okay? So make that change and do the rest of that worksheet.